Okay, we're going to move on to our last measure of spread outness, and that measure is standard deviation. So if you remember, the primary flaw with variance is that it's just simply hard to interpret, hard to get a real meaning for the reader. We know that variance is a measure of spread outness, but if we want a context for it, we need to do something else. And that something else is just simply unsquare it. We're going to unsquare the variance, and when we do, it becomes standard deviation. All right, so the formula for standard deviation is it's just S, right? So if you remember, variance was S squared, right? So when we unsquare it to get standard deviation, it makes sense that it just becomes the S. All right, so we're going to take the square root of variance. So it's the same thing we had in the numerator, which we already know, right? The sum of the squared deviation scores, or sum of squares, divided by n minus 1. Right, but we're going to unsquare it. We're going to take the square root of the whole thing so we can come out and just have standard deviation. You might also see standard deviation with a capital SD or an SD like this. So just kind of be on the lookout. All of those can mean standard deviation. All right, so let's kind of put it all together and practice calculating standard deviation for a very small set of scores. So let's use our 1, 2, 3, 4, 5 again. So remember, that's our set of scores. The first thing, if I look up here and see what I need my sum of squares. So I'm going to calculate sum of squares, x minus the mean, and then squared. All right, and if you remember back to this little data set, or just kind of eyeball it right now, our mean is 3. So x 1 minus 3, 2 minus 3, 3 minus 3, 4 minus 3, 5 minus 3. So what do we get here? Negative 2, negative 1, 0, 1, and 2. And then squaring those, 4, 1, 0, 1, 4. All right, 4, that's 8, 9, 10. So our sum of squares is equal to 10. All right, so using our formula to square root of 10 divided by n minus 1. So I have 5 minus 1 is 4. All right, so the square root of 10 over 4, which is 2.5. So the square root of 2.5 is 1.58. All right, so standard deviation for this little set of scores is 1.58. So standard deviation becomes really useful because it's thought of as the average distance from the mean. So on average, these scores vary 1.58 points around the mean of 3. Okay. Some advantages of standard deviation are that it does consider every score, and we saw that here in the calculation. We involved every single score in the calculation of standard deviation. It removes the influence of sample size, so groups can be compared. So if you look back again, we did take into account sample size. It's specifically sample size minus 1. We remove the influence of that sample size. Now I can compare across groups, where before with sum of squares I could not. It gives a variability estimate in the original units, so that's very useful. It represents the average distance from the mean. All right. Questions to consider. I think we're going to hold off on that because I want to give you a little look into why do we care about standard deviation. So I'm just going to pop in a new slide here so I can write on it. if you think about standard deviation, you've probably heard quite a bit about it. So let's take an example a lot of people know about, and that's IQ. All right? In IQ scores, in education, psychology, they're used a lot. In the general population, IQ scores have a mean of 100. And they also have a standard deviation of 15. All right, so let's talk about what that means. And I'm choosing to mark, if this is 100, I'm going to mark plus and minus 3 standard deviations around the mean. So what I mean by that is if I take my 100 and I add 1 standard deviation, that's going to be 115, 130, 145, it's 45. All right, this one here would be what, 85, 70, 55. Okay. The thing about standard deviation, it comes in really handy when we're talking about a normal curve. And a normal curve, you probably heard talked about as a bell curve. So just pretend like that's a nice, beautiful bell curve. But you have your mean is at the height of your bell or your hump, however you want to think about it. But when we have a normal distribution, we know some really standard things about them. And that is that plus or minus 1 standard deviation, you're going to capture about 68% of your population. So 68% of people have an IQ score that falls in here. It falls plus or minus 1 standard deviation. So 115 to 85 captures about 68% of the people. If you move it out to 2 standard deviations, so this would be plus or minus 2 standard deviations, that's going to capture about 95% of people. So 95% of people have an IQ between 85 and 130. So if you've ever had your IQ tested, or your child or some of your students or clients, and they had an IQ of about 130, then you know their IQ is higher than 95% of the people. So imagine, I'm just trying to make my curve a little nicer. Imagine plus or minus 3 standard deviations. That is going to be equal to 99.6% of the population. So most everybody has an IQ somewhere between 55 and 145. All right, so think about those geniuses you hear about. So they are out here 150, 160. So you can start to see just how very rare those really high or really low IQ scores are. So again, standard deviation comes in handy when we're talking about scores that follow this kind of normal distribution. So most things, characteristics, abilities, intelligence, follow this normal distribution. And a lot of times I kind of joke that the whole world is built on a normal distribution. It's just our place on the distribution changes depending on our what group we're in. You know, if you're sitting in the waiting room at the DMV, the distribution there is going to look different than if you're sitting in the lobby in a building at Harvard or somewhere. So I feel like the normal distribution kind of follows us everywhere. But again, it kind of changes whether we're up here or down here in the middle on that distribution. You know, that's kind of a joke, but I do think it's true. So we're going to start looking plus or minus 3 standard deviations above and below the mean, because we know that's going to capture nearly all of our participants in whatever we're talking about. So again, standard deviation becomes very handy because it is so convenient to talk about and to use. All right, I'm going to stop here and we'll pick up with our next topic.